Welcome to myprojectbuzzer.com. Our product title is Fixed Point Computing Element Design for Transcendental Functions and Primary Operations in Speech Processing. The abstract: in our product, we are going to process the speech signal by means of VLSI system. The speech signal processing mainly involves the integration of mathematical operation and logical operations. Here in our product, the mathematical operations are implemented by means of using redundant logic gates. These logic gates perform the operation of the speech signal processing for the mathematical computation and computation of the speech signal. The modular flow diagram: in our product, the voice signal is to be mainly processed. The signal processing mainly involves the mathematical computation and computation of speech signal. The mathematical computation involves the logarithmic computation and the exponential computation. The key integration for the computation of the speech signal is mainly performed by the convolution, windowing, and polynomial expressions. In our product, we are going to calculate the logarithmic unit and exponential unit operations in the mathematical computation unit. This computation of the speech processing is also performed by the proposed design. Initially, the processed voice input data is taken in form of binary bits. These binary bits are splitted into two binary input datas. These binary input datas are fed as the input to the RAM. The RAM write enable signal is given, and hence the RAM writes the binary data into the RAM. The RAM has two write enable signals, and the output data is enabled only when the RAM output enable signal is high. Once the RAM output enable is high, the value from the RAM is provided to the mathematical computation unit, and hence here the RAM works as the temporary storage. Here in our product, the mathematical computation unit, the operations are being controlled by means of a controller. For the controller, there are three input signals: the active, the mode, the order. The active signal enables the controller, and hence only the controller performs the controlling action in the mathematical computation unit, and hence for working of the mathematical computation unit, the active signal must be provided to the controller. The mode. The mode instructs the controller how to perform the mathematical operations in the mathematical computation unit. There are two modes, the mode 0 and the mode 1. According to two modes, the mathematical computation operations are being performed in the mathematical computation unit by the signals from the controller. Initially, for mode 0, the value from ideal state is being transferred to the binary linear algorithm and the exponential squaring value, and for prior and it is of the polynomial convolution and the windowing. The order of the polynomial is given to the controller, and the logarithmic unit value and the exponential unit value powers are being defined in the order of the polynomial computation unit. Now the working of the mathematical computation unit. The values from the RAM is fed into the mathematical computation unit, and we are providing the active high signal, and the controller sends the value of mode 0 or mode 1 and the order of the polynomial. According to mode 0, the logarithmic unit and exponential unit performs its operation and sends the processed output data. In mode 1, another sequence of logarithmic and exponential operations are being performed, and the output data is being retrieved. by the order of the polynomial. The logarithmic powers and the exponential powers are being defined, and the mathematical computations are performed with redundant logic gates, simple hardware architecture, and our processed output data is being obtained. For both the mode of operations, the controller unit is reused again and again, and hence it proves its computation latency and its hardware efficiency. Open the Xilinx ISC design simulator and run the program. Provide the data to the clock signal. Provide the value for the binary input data, the processed value. Select the mux array selector value. Provide the value for the RAM write enable. Provide the RAM address value. Run the program. The values are being written in the RAM registers. Provide the value for the RAM output enable signal. Now the RAM values are sent to the input of the mathematical computation unit. Provide the value for the active signal. Provide the value for the mode signal. Provide the value for the order of the polynomial. Then provide the input for the mux select signal. Provide the value for the register reset signal. By running the program, our processor output data is being obtained. Next is the RTL schematic and the technological schematic. For the RTL schematic, view RTL, start with Explorer window, press OK, and add FPCE, create schematic, and our required schematic of the proposed system has been obtained. For viewing the technological schematic, view technological schematic and start with Explorer wizard, add FPCE, create schematic. In the create schematic, we are able to obtain the output of the technological schematic values. Hence our required technological schematic is being obtained. For knowing the value of the device utilization and timing summary, click Design Summary Report and Synthesis Report. Now we are able to view the design utilization summary. In the design utilization summary, the number of LUT used, number of LUT flip-flop values, bonded input-output values used is being obtained. For the timing summary, click timing summary. In the timing summary, we can able to analyze the number of nanoseconds the process is being performed. For calculating the power of the process, use the Xilinx power estimator tool and provides the value of the number of LUT used, number of flip-flop used, and number of bonded RAM used. Press OK and click yes. Hence our product power is being obtained.